Serial communication in Arduino is one of the primary features, as this method is very useful for program uploading, program debugging, and communicating with other devices. So in this lesson, I'll explain this property in details. First, you should know what is serial communication, and to do that, let me show you an example. This is an appearance, and this is another appearance. Now you have seen these two. What are the differences? In first one, all the 8 bits came at once. In the second one, the bit sequence came in one by one manner. These are the two communication methods supported by most of the microcontrollers. First one is known as parallel communication method, and second one is known as serial communication method. Parallel communication is like sending 8 bits through 8 pins. Suppose you want to control 8 LEDs connected in 8 pins of a microcontroller, then you can use this method to control the LED. Whereas serial communication in microcontrollers is like sending a byte over one pin and receiving a byte in another pin. Clearly, this method is the slower one, but it uses lesser number of pins. In microcontrollers, 2 pins can be found, RX and TX. RX is responsible for receiving a byte. TX is responsible for transmitting a byte. If these 2 pins are found in the pin diagram of a microcontroller, then be assured that the microcontroller supports serial communication. When we plan to send data or bits over a long distance, we always prefer serial communication over parallel. Now, why we do that? Let's understand this through an example I'm giving you. Suppose you want to control a LED sequence which is situated almost 5 meters away from the controller. In normal scenario, if you apply the parallel communication method, then you can connect each LED with a pin and send bits to control the LEDs. The problem you will face is data loss, which will lead to another problem, that is finding the faults. Think you are checking a 500-meter long cable to find out where the cable is teared off. Perhaps it is very difficult for a 5-volt signal to cover a 500-meter distance through a cable. Here serial communication comes into picture. Serial communication offers many protocol standards such as RS-232, RS-485, which are capable to send data up to 1 kilometer. Otherwise, you can also use wireless modems to send data if you want to achieve greater distances. There also a serial communication method is needed. Serial communication also supports error checking algos to reduce the data loss. If the receiver didn't receive the data properly, it may request the sender to send the data again. This type of method exists in serial communication standards. Now I guess you have understood why we need a serial communication. For a microcontroller like Atmega 328P in Arduino Uno board, UART is needed to support serial communication. UART stands for Universal Asynchronous Receiver Transmitter. In Atmega 328P, it has USART, which is Universal Synchronous Asynchronous Receiver Transmitter. That means it supports both synchronous and asynchronous. Moreover, UART brings these 3 things, and you should know the concepts. First one is a shift register. It is there inside the Atmega 328P controller. It is known as buffer. When you transmit something, you must copy the data to buffer, and when you receive something, you must copy the data from the buffer. So a received data is first stored in the buffer. In Atmega 328P, the buffer is of 8 bits. You can transmit and receive a byte of data at a time. Now the second one is a baud rate register. Technically, baud rate is symbols per second. Baud rate often decides the speed of communication. A successful communication between a sender and a receiver is possible only when they both negotiate on the speed. In asynchronous communication, they may have a different clock frequency. That's why a speed should be fixed. The unit of this speed is measured in bits per second. In Arduino, you can fix this speed by choosing a value from a known table. So this is a table. Here 9600 is the most used baud rate and supported by many devices. Now come to the third concept, that is presence of RxTx. RxTx pins are there in microcontrollers, as I have already mentioned that if these pins are present, that means the microcontroller has UART inside and the controller is compatible with serial communication. So Rx is responsible for receiving a byte into the buffer. Tx is responsible for transmitting a byte from the buffer. So to and from are the keywords. Now, how Arduino Uno hardware implements serial communication? See this board picture. It has USB port to communicate with computer. USB means Universal Serial Bus. So Arduino can communicate with PC via serial communication. The microcontroller doesn't support USB protocol. It supports TTL. So the USB signals coming from a computer is not directly received by the controller. There is an USB UART bridge which converts the USB signals into TTL and TTL signals to USB. That way microcontroller communicates with computer. Here is the RxTx pair in pins 0 and 1. Though it is connected with the USB UART bridge, but there is extension available. See, these are the extension. So you can connect other devices to these pins separately for separate applications. How Arduino IDE implements serial communication in software? It is done by an object called serial. Let me show you how you can use serial object to implement serial communication in Arduino. There are important functions of serial. Is used to set the baud rate, and we can write we can use begin like serial.begin within bracket 9600. Now here 9600 is the baud rate, so baud rate is set at 9600 bits per second. That's the meaning of this line. Another function is read. This function is used to read the incoming data. And how we can write the read or use the read function? Like this, char c, here c is the character type variable, is equal to serial.read. Now read returns a character. Read is the function which can return a character. So it will return the incoming character of 1 byte. Basically, serial.read is used to read the buffer and store it in some variable. Here I have used this variable called c. There is another function called print or println. It is used to send data of 1 byte. So when we are using serial.print within bracket data, it sends the data through tx pin. When we are using serial.println within bracket data, it sends the data with a carriage return and line feed. So if you want a new line, then use this println. This function is very important, that is available. It is used to check whether there is an incoming data is present or not. How we write that? Serial.available, this function always returns 0 when there is no incoming data. It will return 1 or it will return true when there is incoming data available. So whenever you are checking whether there is an incoming data available or not, you can use this function. I'll show you how to use this function. There are tools provided by Arduino IDE which are serial monitor. Serial monitor is used to show all incoming data coming from other devices to PC. So we can give inputs from keyboard to send data using this serial monitor. So serial monitor can be used for both communication, like transmission from PC and reception to PC. Both process we can do using serial monitor. There is a tool called serial plotter, plot graph with incoming data. At a time 2-3 graphs can be plotted. Suppose you have 3 sensors and you are reading these sensors and sending the values to PC in comma separated value format, like sensor 1 value, comma sensor 2 value, comma sensor 3 value, and you are sending this as a string. Then these comma separated value can be decoded and can be plotted using serial plotter. So this is the important tool. I'll show you how to use serial plotter in some sensors. So to establish the both way communication, I'll do an experiment with Arduino and a computer. My methodology will be Arduino will ask the computer to send capital L to switch on the LED on board and capital N to switch it off. So from PC's keyboard, inputs can be given and the inputs will go to Arduino, and then Arduino will act accordingly. I'll write that program. And for the circuit, no external components required. We have onboard LED at pin 13 and I need only the USB programming cable. So let's write the code first. I'll open Arduino first. Now let me maximize it. So first I'll define the 13th pin as LED. Now inside void setup, I'll write serial.begin 9600. That means I am setting up the baud rate. Now here inside void loop, I'll write serial.println within bracket, enter L to switch on and N to switch off the LED. Then serial.available. This will return true if there is an incoming data. So then the if statement will also be true. Now character val within bracket serial.read. So whatever incoming data it is, it will be stored in this val variable. So if val is equal to the character L, then digital write LED is high. Now if this val is equal to character N, then LED is off. That's what our objective was. Let me write it. Digital write within bracket LED, comma, low. So this is my simple program. First it will transmit the enter L to switch on and N to switch off. Then if I press some data from the keyboard, then it will be stored in val. And then if that data is equal to L, then high, otherwise low. Now here, let me save the program as serial. So now my program is completed. Let me put a delay so that the string which is coming on the serial monitor will be slower. Let me upload the program. Now here I am pressing L. No, LED is not working. That means I forgot something. I forgot a thing to be done. So what is that? It can happen with you also. That is, I have defined 13th pin as LED but forgot to configure the pin mode. Now let me write LED, output. By this line I am configuring pin 13 as the output. Now it will work. So let me re-upload the program. Now let's check. Now here this enter L to switch on and N to switch off is coming after 400 milliseconds. I am pressing L, this switch on, N switch off, L switch on, N switch off. This is how it works. In the next lesson, I'll discuss the function analog read.